Okay, so the question is longest consecutive sequence. The question given an array of non-negative integers. Find the length of longest subsequence such that elements in the subsequence are consecutive integers. The consecutive numbers can be any order. Okay, so here we have to find it out the longest consecutive sequence. Consecutive sequence means you can see here 1 2 3 4 5 6. Okay, so in the order. Okay, so every element is greater than 1 its previous element. It's so simple, there's no too hard thing. You can see 1 sorry 9 10 11 12 13 14 15. Okay, so let's take this as our example and first think about how we will solve this. Okay, so again, the constraint is 1 to 10 raised to 5, 0. Expected time complexity is O of n, and space complexity is O of n as well. So as here they have written O of n and O of n both, then there is no need to sort it. Okay, so first we will sort it, and again after that we will store it somewhere because as space is O of n. Okay, so the logic behind sorting, if we sort the given array, okay, so here I'm just sorting this as the first example 1 2 3 4 5 6, okay, and 9, right? After sorting we will get this as our sorted array from above thing. Okay, as you can see here 1 2 3 4 5 6, it's a consecutive array elements, longest consecutive. So here, as you see, the logic is so simple. The This is our first element, this element, okay, this is second element, this element is greater than its previous element and it's just incremented by 1. So the simple logic here, array of I equal to array of I minus 1 plus 1. Okay, this one. Okay, so if we found like this way, so we just have to add it to our answer. Okay, else what we have to do, okay, if this is the condition, else what we have to do here, just take this as a scenario. Okay, if there is no such like element, then we just have to update answer as 1. Okay, and the other value is array of that index for the next time. To consider this as our example, okay, so let's take another example here. Suppose we found 4 as twice. Okay, so this, the consecutive elements will be 1 to 6. Okay, so if 4 is repeated twice, then here only one condition. Okay, so array element is equal to array of I plus 1. Okay, so at this moment we just have to continue this step, right? There is no nothing. And one more thing, after sorting, uh, is there anything left? Okay, so I think it's enough. We just have to find it out here, the maximum value at each point, that is answer or maxi something, and we just have to return it the maximum. Okay, so here is the complete code for this. I have already written here. I have sorted this array. After that, I have just declared all these things, the count and value. First time we have to store somewhere value. Here the array right now, the these elements. Let's take this as our example. Okay, so this is our sorted, right? This is our sorted array. Okay, so let's take this as our example here to try run out. So the first time Okay, here 2 is equal to value plus 1, right? It's 2. The count will be increased as 2 and the value is updated to 2. Okay, the second time it will move to the next step and answer is updated. Okay, so here the answer is 2. All the iteration, if you can see the each iteration at each point, then the same procedure follow. We will get our answer as 6. Okay, here the same, the another approach here as in the expected time complexity here O of n and space complexity O of n. So think about another map, right? So we will store each index and its occurrence. Okay, how many times? If it is occurred, then we just update it as 1. Okay, if it is not, then fine. Okay, so here 1 occurred 1, 6 occurred 1, 1 occurred 1 times, 9 occurred 1 time, 4 occurred 1 time, 5 occurred 1 times, 3 occurred 1 times. Okay, so here what we have to do, I have just stored all the elements and its occurrence in unordered map. Now we can traverse again array. Okay, and while traversing we just have to check this element, is there any previous element for this, means what, 2 minus 1, like 1 is present in unordered map. If it is present, then we just have to move to the next element. Okay, here 6 minus 1, 5 is present, right? So we will move to the next element. Here 1 is present, 1 minus 1 is 0, so 0 is not present, so we will continue in that case and we just check 2 is present, 3 is present, 4 is present, how many continuous elements are present. Okay, and if all the elements are like 6, here the 6 elements are present, so after 6 the count and maximum answer will be updated. And okay, so the next element is 9, so 9 minus 1, 8, 8 is present, no, so we will move for this as well. So here the answer is count is 1. Okay, so this will not update in our answer because already the maximum longest consecutive sequence we found. Okay, so here is the logic behind that. What we did, we stored in another map. Okay, at each element, or we just check its previous element is present in another map. If it is not present, then we have to just check, we have to count the other further next elements. Okay, it's so simple. Here the time complexity and space complexity meet our goal. Okay, and for this the time complexity is O of n log n. Okay, because we are sorting it out. Okay, thank you.